Hello everyone, welcome to this new TouchDesigner tutorial. In this tutorial we were following the series of parametric equations, and we're gonna build this network for making this beautiful math curve. Okay, what is the butterfly curve. I found this curve in a book that I read about mathematics, and I wanted to recreate the curve because I think it's beautiful, and also they were the parametric equations of this, so why not have this fun? Okay, so we're gonna end with a network like this, and yeah, I'm gonna put this aside if I need to guide me in steps. And here in the Wolfram page, you can find the butterfly curve. You can see there's a lot of information, but the information we need it's here, that they are the parametric equations. So we're gonna build this with chops. Okay, so yes, we're gonna start right now. So we're gonna open a new file. In this new file, I think I'm gonna start something different than the Spanish tutorial. And first we're gonna build the geometry network and the render network, and then we're gonna build the parametric equations. So we need to place first a circle sub. After this circle sub, we used to need we're gonna connect, sorry, transform. And here we're gonna edit this scale. For now we're gonna divide by 30, and finally we connect a null. After this we're gonna connect the geometry, then we need to use the camera, and finally we use a constant material and we drag it to the geometry. After this we use and place a render top. On the render top, we go to common and select the resolution 1280 by 1280. We can change here the pixel format to 16-bit. Finally, we add a transform for the background. So we put one here on the alpha and turn on the comp over background color. And finally, we use a null. This null, we can make it active, we can change it to BG, and we will split into our screen, and on the right side we select top viewer, and on the right side we're gonna see the network, but we need to quit the backdrop tops. Okay, so yeah, that's it for the sub. We also can turn on the stancing on for now, and yeah, that's it. Also we need to change the camera, the view to orthographic, and the ortho width maybe like 6 for now. Yeah. Okay, so after this we're gonna declare two variables or parameters with the constant. Okay, and this constant, first we're gonna declare our samples and then the cycles. Oops, cycles. Okay, so samples, now we need 101 cycle. We can connect a null, and yeah, we are good for now. So I'm gonna go back and forth with the Wolfram page to see the parts of the equation that we need to recreate. So the first one, if we see, if we have sine and cosine of t. Okay, so first we need to use a pattern chop to declare our cycle. The type needs to be to ramp, and then we export these samples to the length parameter. And as we're working with radians, we need to convert this to radians, and one full cycle it's 2p. So we're gonna type here in the to range parameter from 0 to mat p multiplied by 2. And finally we can change here to t, and then, so we can also change the name of the chop, so we can see the steps that we are doing and the part of the equations that we are doing uh, for this parametric equation. So first, as we see, we need to use a function because we need to declare first the sign, and we need to change the angle units to radians because we're working with radians. Okay, and now you can see that it's working good. And we change here to sign, and here we can copy and paste and only change here to cos and select cos. Oh, sorry, to change the name to cos. Okay, so yeah, we have the first part of the equation, and then this second part is the same for both of them. So we will use all of this, and the only thing that will change, it will be this multiplication at the end of the equation. Okay, so first we need to construct this e that it's multiplied to the power of cos t. So we have cos t, and from here we can connect another function, and on this function we were gonna select the function that is exp, that is e at the input. Okay, so oops, here, and we have now this e cos t, and yeah, that part it's solved. Then we need to use minus 2 cos t, cos of 4t, and the way that we construct this, it's going from here to here, in I mean backwards. So first I'm gonna connect here a mat, and we're gonna multiply this by 4, and we have this 40. Then we connect a function, or we can also copy this because it's cosine, copy and paste, and we connect the 40 to this input, and now we have 4t, sorry, cos 4t. And finally we use a mat because we need to multiply this by 2. So yeah, we have here 2 cos 4t, and now we have this part solved. And then we need to make this a sine of t. This is 1/12 of t, and or could be t divided by 12, and then the sine of this and multiply by the 5 exponent. Okay, so we're gonna use here math. Oops. And this math will be t divided by 12. So we're gonna go to the add and divide on the multiply 1 divided by 12, and we have that part. Now then we use a sin, but we can copy and paste this because it is set with the angle, with the requirements that we need, and we just need to connect it, and now we have sine of t divided by 12. And finally we connect another function, and this function we will select the that will be this one, input to the exponent. So this is our input, and the exponent value will be 5. And yeah, that's it. So here is sin 5 t12. And now we are with each of these guys, and then we need to make these operations, and we're finding it. So I'm gonna select here, and first I'm gonna select equals t. I'm gonna copy and paste the select, and then 2 equals t, and here we use a mat and connect the select to, and we change the combine chops to subtract. This is the first part, and then we copy this select, and we select this sine 5t divided by 12, and we're gonna use another mat, and this mat will be combine chops to add. And yeah, that's the final part of this equation here, and then we're gonna multiply by sine for x and by cosine for y. Okay, so here we're gonna do a select, and we're gonna then connect after this mat another mat, and here, and this select, we're gonna select first sine, and here on combine chops we select multiply, and then we can copy and paste these two, and here we in this select we only select cosine, and yeah, we have our x and y axis. So I'm gonna put this aside. Oops. Ooh, sorry. So I'm gonna make I'm gonna make some space with this here. I'm gonna go back this to here, and here finally we need to use a merge, and this merge we're gonna connect a rename, and finally we use a null. So in the rename we rename to tx and ty, and this null can be positions, and we're gonna drag this positions chop to the translate op, and select translate y to tx, and tx to translate x, and ty to translate y, and then you can see that beautiful butterfly. I'm gonna make here some changes, the ortho width to 8 and the transform to 0.6, so it's almost in the center. And yeah, that's it for the curve, but I'm gonna give you some more steps so you can have more dynamic this beautiful curve. Okay, so the first one, we need to add a noise chop, the noise stop, sorry. In the command page we select samples, and to resolution width and to resolution height we put 1 because we need the same amount of samples of here, and we change the pixel format to 2-bit float mono, and after this you can use a mat, and finally a null, and this null we rename it to scale. Okay, we go to the geometry instance 1 page and drag the scale to the scale op and select R for all of the three scales, and you can see that it's now scale. So you can have more randomness. You can play with this, but I'm gonna make it like this. And here on the multi-add, you can increment this variation. So I'm gonna put it like 2. And also remember, you can have motion with the time dot seconds multiplied by 0.3. And now you can see that the scale of every sample is changing, and you have now a more random distribution of or scale of these samples over the butterfly curve. Also, you can copy and paste this. We delete the second math and we rename the scale to color. And here you can use a lookup, and you can make here like a ramp and to look up on those colors, or you can use the color lover speaker talks that is available in the derivative page that will help you to have beautiful outputs immediately. Okay, so here on the lookup we need to change our pixel format to 32-bit float RGB, because it was by default for this noise by sorry, to monochrome. So if we change, yeah, here we can see the colors that are lookup with this noise. Here on this noise we can change it to seed, and then we drag this to the instance to page of the geometry, to the color OP, and select their respective channels, and voila, there are some colors and you can change them very fast. So I'm gonna leave this, and yeah, that's it. We can do also some post effects. I'm gonna use the palette, so we can add bloom and blur, sorry, and feedback. And then we connect first the feedback and then the bloom, and after the bloom we connect the transform. Okay, so I'm gonna close this and these viewers to not have FPX drops. So here you can see that let me see, it's working this. I don't know. Oh yeah. Also, we can change this, or we can play with the phase of the cycle. So we will have movement around these samples, and that's a good effect too. So you can see it here. So I'm gonna use again the time dot seconds, and we need to multiply by a very small value. And now you can see that feedback working good. So maybe here, and I'm gonna change the dry wet. You can play it the way you want with this, and then we connect now the bloom. And here I don't like the glow. I don't want to have any other color than the ones that are by default. So glow level goes to 0 and ramp glow level goes to 0, and then we change the threshold, and the bloom level we level up, and yeah, you can blow the intensity, but you can see it. So there is it. Yeah, so you can play it with your own settings. Okay, so I'm gonna leave it like this, and yeah, that's almost it. We only need to add an extra operator, because if you remember, we declare here cycles. So this is one cycle, but if we add more cycles, this can have more shapes over the others, and that also looks beautiful. So here I'm gonna put matte, and we're gonna drag to the multi-add page the cycle parameter to the multiply parameter. And now if you change here cycles to 2, you can see that we have now two curves, one a little bit greater than the other, but you can go crazy with this, so maybe 8. But as you can see, now we have more movement, because there is the same velocity for the same amount of samples, but with more cycles. So then you need to change here maybe to 0.001 or 0.005. Yeah, and you can add also more samples as you desire, so maybe 400, and you can see that, yeah, it's working good. Maybe the opacity, yeah. Well, pues that's it. This is the tutorial. I hope you like it and learn something from this, and how to use and interpret mathematics inside TouchDesigner. So yeah, finally I want to tell you that this file that will be available for patrons will have the chop network and also the top network, that is almost the same, but with tops. So you have the two versions, and you can see that both are working very good, and we don't have any FPS drop. And yeah, so that's it, guys. Thank you so much again, and I want to thank to all my patrons for your patience and support. I know I having no so much activity with tutorials these last months, but I have to um, check how to make time available for this with my other life. Yeah. So, but remember, I always want to share knowledge and make it available for you. So thank you again, and see